Okay, before the break, we were going over some of the physics things. We talked a little bit about Newtonian physics, and the computer's generally going to handle the calculation for us. We just have to know when to use certain things for what we want to happen in our code. That's going to come with a little bit of practice and experience, and we're going through here based with all these boxes, and that's something you're going to want to do as you're reading going through the reading assignment this week. Maybe you have open and click on the different boxes and see what happens as you make changes on things, turn different check boxes off. There are a few things we might have to mess with. Oops, words like that. So we kind of set a mass about an average male mass there, has a very high normal gravity. This is one calculation that might show up. We were looking at when we started applying angular and linear velocities. If we do something small like move a speed of 1 in the forward direction, it can't really overcome friction. It's just going to fall over because of the imbalance friction pulling. Friction is going to pull back at an acceleration that far exceeds that 1 forward. At a certain point, it's going to go past it, still kind of bounce around, go further. There's probably a subtle one we could get into where it balances out nicely and the character moves along smoothly because the linear speed we find perfectly matches the friction or what we're getting from the friction, which would also show up a little bit more here. So if we were to say, let's start going 10 in the y direction, it went up at first because when the game first started running, that object was just sitting somewhere, right? It has a zero velocity as it started moving. Gravity's going to start trying to accelerate it. So it was able to go up at first. Then it came down, and there's a constant upward acceleration, but nothing's happening, right? And that's that number. Oh, I already erased it from the board, right? That's the one we might need to check on a calculator from time to time. So has a mass of 75, gravity's pulling down at 10. That gives us a rather large number, like it's going 750 meters per second faster every second. So that's the number we have to overcome, right? And start typing in big numbers. I'll get these buttons out of the way. Meeting controls, there we go. So up to 200. Oops, did I put that in the wrong box? That looked like it went in the X direction.
Does it need to be negative 200?
Negative would be down. So the positive y goes up. Okay. So the opposite of the 2D game. You can always tell because of
I thought you were trying to get it to. I thought you were trying to tell it how fast to hold down.
I was trying to get it to go straight up.
You just have to wait for it to come back.
Yeah, because it's starting at 0. Yeah, I was trying to get it to where it looked like it was jumping. So, and remember, velocity doesn't necessarily correlate perfectly to the acceleration. 40. Positive y has a mass of 75, yeah. Still shooting off pretty quick, but if that's constant and gravity is constantly accelerating it, it will come back down eventually. And when it does, it's not nearly enough to lift it off the ground again. So little things like that, again, a big warning about, trying to control things with velocity, because velocity never changes. We can't apply a force to it, and we're back to that Newton's first law. If we do constant velocity, there's no way we can change the forces if we're always worried with that. So keep an eye out for that. Couple other things we want to look at here. I don't know. Let me put something in this so you can see the angular velocity. I'll like spin around the X. Oh, not fast enough apparently. Let me try putting 10 there. Which is basically just tell it to fall over. Put a big number in there. I'll put 100 in there. Oh, any bigger than that apparently. I was trying to get it to spin a few times before it falls down. Maybe if it started further up. There we go. There. So yeah, the angular velocity is just spinning like that. That one isn't as unpredictable as trying to code with the linear velocities. Damping is like friction, air resistance, water resistance, depending on what you're moving through or across. How much does it slow down over time? That's the basic idea on those. They're all there. We just ready for us to work with. Collision layers and collision mask are a little bit different. So the layer is what layer it exists on. And mask is the layer that it's looking at. So for example, if we go to the ground and we can see it's on layer 1, and maybe instead of looking at things on layer 1, I'm going to switch it to look at things on layer 2. So it's on 1 and it's set to interact with things on layer 2. We'll come back over to the object, maybe move it to layer 3, take it off layer 1 and interacts with stuff on layer 1. I'll move both of them to 3. And it should no longer see the ground. Yeah. So the ground is on layer 1. So if it's looking at layer 1, or if it's not looking at layer 1, that's what the mask is. What does it see and where is it at? The ground's looking at layer 2. So if I put the object on layer 2, it still doesn't see the ground. So notice which one kind of takes precedence there. The static body should have been able to see the rigid body, but the rigid body couldn't see the static body, and it passed right through it. So as if it was non-existent. So you can see that the rigid body is the one that's going to be doing the looking. Because if it's looking at layer 1, no matter which layer it's on, I'll move it over here to 4. And as I toggle those on and off, you can see that it can handle more than one. So as long as it sees whatever layer the ground's on. This is going to be a big deal really like next week. So next week's reading assignment is about collisions and triggers and other events we have. Collisions and signals is really the big one. But we've been doing that since like the first day of class. It's kind of taken for granted. Collisions were taken for granted, like the very first example we did. But it's the reading assignment for module 4, because we can't we can't access most of the properties in a collision. All the stuff we have available in a collision and signals, we can't access until after physics. So that's why it's in next week's reading instead of module 1 reading. If I hover over the layers here though, you see sort of an advantage in that default name. Notice it's called bit 0. So that detection only uses one, it only uses 1 bit. So very, very effective. Layer 1 bit 0 doesn't really tell us much. And the project settings is another one that you'll often come up with, project and project settings, and set your layers down under we're talking about physics, right? It's set to the 9.8 meters per second squared for gravity in the negative y direction. But you can, right there is where you would go to change that. Then under layer names, we have rendering layers and physics layers. We'll get to rendering layers before long. If we go into physics layers, we can rename these. So let's make layer 1 the ground, layer 2 the object, and layer 3 other, for kind of that thing we were just looking at, and give it meaningful names so then you can organize things. So you have like a background and maybe a background layer, which is stuff that the game doesn't really interact with. It's all just to make it look nice, fill in the space. Then you have the actual map of the world you're going interacting with, but give it a meaningful name, right? Maybe there's some sections where there's water and other sections where there's air, right? And then if your character's underwater, it's going to move slower because there's going to be water resistance, and the damping we get from water is going to be larger than the damping we get from air, just because there's more resistance. So the same amount of force can't move as fast. But that's another one we often want to come in and rename those layers so we can keep track of them. So you see now, when we hover over it, it says what each one is. So if I put the object on layer 2 and it's looking at the ground, but I say look at other, this is where the physics no longer apply. It's going to pass right through the ground. So sometimes we want that. We don't want everything interacting with everything every time. And we can do, they're independent, so we can check multiple things at once. So just keep those in mind really when we get to next week's reading assignment and stuff like that. As we go down the transform data, and all of this we've seen before, this is accessible from your script, right? If we hover over something, you can change that. So when we get over to our script, you can see that it is just our object has a right. So object dot collision layer, and we can just change that to whatever we want. The thing to notice though is there are 8 bits. We have a bit 0 through bit 7. So you would assign it an integer, right? 8 bits can go from 0 to 128. Which ones do you want on? So bit 0, everybody remember how to read binary numbers? So bit 0 would be the 2 to the 0th power, our ones column. Bit 1. So if we put a 1 in there, which is just 0, 0, 0, 0, 0, 0, 0, 1, that's going to turn on the first bit. For layer 2, that's just the bit 2 is a 1 in just the zeros column. So think of it as entering a binary number. So let me turn a couple on here. And the way it's set up here and in all of our other game engines, they always put bit 0 at the top left. It's reading a binary integer backwards. So like bit 8, that's or bit 7, that's our largest number, right? That's to the 7th power of the 128 column. So this is 0, 1, 0, 1, 0, 0, 1, 1. So when you assign it, you give it an integer to turn on whichever bits there are. So you might have to think through what binary number you want to do that in your code. Maybe we have a 1. If you just want one single layer, right, it's going to be a 1, 2. The 3 would actually be an 8. Right? That's 1, 0, 0. 4 would be 16, so 1, 0, 0, 0. 5's at 32. Does that make sense? You can see how they're laying up there. All you want. Oh, it says it over and over it. Bit 2 is a 4. Oh, I skipped 4. Then bit 3 is 8. Bit 4 or layer 5 is 16. And you can also find the number you need just for adding them up. So if you wanted it on something like on 2, 4, and 5, that's a 2, an 8, and a 16. If we add those together, we get 26. So entering 26, that's the binary for 26. Is how to read those hints when you need to do that in your script, because it's a little odd to at first try to remember those. And almost all of our game engines have the layers set up that way. We enter the binary, we enter the integer for the binary bits we want. But where do we exist at, and what are we looking at? Transform data, and then yeah. I'm probably good on that part. So when you're ready to when you go through the reading assignment, have something like that open. Just a couple objects, whether it's 2D or 3D. And as you read about the things, click around to see where they're at so you can tell what's going on with them. Just a quick note on something else. More board notes. Not going to get super in depth, but probability is very important. We want to have interesting things happening in our game. We don't want completely random, because some things are more likely to happen than others. Anybody in here play D&D? It's a fairly common game for computer, right? So that's one way we can handle it. The DM's going to choose different things that happen. I linked in the learning materials. In the supplemental reading material this week, or supplemental resources, there's this really interesting study come out recently, and I found a simplified version of it. The actual study itself is kind of a hard read for even doctoral level mathematics, the guys that wrote it, but very, very complicated stuff, and it ties into in neuroscience and all sorts of it's very, very high level, the actual research, but there's after about 3 months, somebody was able to kind of simplify it and give a good explanation of it, to make video games more engaging based off like neuroscience and different psychological impacts that we know and stuff, and fitting people's expectations. So that's an interesting read if you want to read that instead of just raw probability. That has to do with the density functions and stuff that you may not have seen in math, any of your math classes, but at least gives a different perspective on it. basic probability, the chance something's gonna happen. Right, it's a number somewhere. I'll just write P for the variable. Somewhere between never gonna happen, a 0% chance, and a 100% chance. Absolute certainty, right? Impossible, 0 and 100%, or 1 is absolute certainty. It's going to happen every single time. We can pull in random numbers and just choose something like that, something in that range, right? Choose a random number if that random number is less than 33, or 0.133, 0.33. I said that all kinds of wrong. So we choose a random number somewhere between 0 and 1, and then set up our code that, like, if it's less than 0.333 or 1/3, then that's like a 33% chance it's going to happen. 1 out of every 3 times it's going to happen. So maybe different colors of opponents. There's some red guys, some yellow guys, and blue guys, and they each have different power levels. Some are harder than others. And with the blue guys are the weak ones, we want a bunch of them coming at our character, our player, all at once, because they're easy to defeat and build up skill level. So there's like a 1 in 3 chance that the opponent is going to be the blue. But maybe the red guys are the really, really tough ones, hard to beat. We probably only want that to happen, like, not instead of a 1 in 3 chance, maybe something more like a 1 in 50 chance. Otherwise, our player is going to have a really hard time defeating the hard opponents. So just some basic stuff on probabilities. Mostly what I wanted to put up here was, how do we think about them? So you can think about them in terms of percentages. Set up your selection structure kind of like what I just said. We choose our random numbers, which we just say random number. The default random is a number somewhere between 0 and 1, which the way computers are set up, it does not include 1. Includes 0, but not 1, but so there's no 100% chance. And then we just take that number and consider that as a percentage. There's a 30% chance, or a 48% chance, or a 76% chance that a certain thing is going to happen. Depending on how your brain works, it might be something. Right, so R is random number, and if R is less than 0.33, we do a bunch of stuff, and that's like saying a 33% chance. Let's write that bigger. Does that make sense? Everybody seen that before? Hopefully what percentage is makes sense. But all of our brains work differently. Some, maybe like odds. Thinking about doing an odds like we would call sporting events or something. That's the way I kept saying it a moment ago, right? So like a 1 to 3 chance, or is a fraction. One chance it will happen out of 3 different things that could possibly happen, or 1 in 7. I'm drawing math stuff up here, but I want you to think about the words part, because this is how we think about stuff. So in your code, you'd probably choose a random int. R is rand int any 3, but I'll do 1 to 3, including 3. Wait, they'll probably use Python. So 0 to 3, not including 3. So 0, 1, and 2. There's 3 different numbers, and if
R is equal to, say, a 2, we'll do some stuff. So there's our 1 in 3 chance.
And the other way that can be really helpful for thinking about probability is like in a D&D game, we're rolling a dice, board games. Think about rolling a dice, they're in the normal 6-sided die, there's 1 in 6 chance of getting one side of the die, or a 20-sided die, or a 3-sided die. And when we code it up, we can choose any of them. It's probably going to follow like odds, but I'll put like dice. So maybe you can choose any random number, right? Think of however many times you want it to happen, and the bottom number of your fraction would be the number of sides you want on your dice. So like a 14-sided die, R would be a random integer somewhere between 0 and 15, not including 15. So I'm using Python syntax here. And then if R is, say, less than, we can adjust it, right? So maybe R is less than 5. That's going to be our basic stuff. Otherwise, if R is less than 7, right? 5 chances for the first thing to happen. Only 2 chances for the next thing to happen. I'll put interesting. And if R is less than 8, something very special is going to happen. And otherwise, I'm out of room. Maybe nothing happens otherwise. But it doesn't have to be a perfectly even distribution. So it's kind of like odds. And in a long roundabout way, it gets back to this. Depending on what you're most comfortable with, obviously write the code the way you're comfortable with it. But if you're using just the random percentages, think about how you would say it in a sentence talking to your friends, right? It's like, there's a 47% chance something's going to happen. Usually people that are big in sports are very comfortable with odds and can make a lot of sense out of that. And you just break it down into fraction. One that a lot of people that play games are often most comfortable with it in the form of like dice. In which case it goes back to just like the odds, think about it in terms of a fraction, but saying it as a sentence like you were talking to your friends, and think the number of sides on your die is the bottom of the fraction, and then you just choose different numbers for the top to be how likely a certain event is going to happen. You don't want things to be completely random, right? If it's completely random, the player is not going to have any way of predicting when things happen. They don't know when to expect other enemies or NPCs or something to show up. And we want the player to have some expectation and foresight into what's going to happen, so they can kind of be prepared for upcoming things. But just a little note about how we code those in and how we approach the numbers, just the odds that something's going to happen. And you want it, when you're putting your game together, you want it to be very very well controlled when events happen and things change, and allow the player to get that expectation. That's kind of what that article is about. I believe that one that I linked to does have a link to the original article, the high level one. If anybody's interested in that, you can follow the link. If it doesn't, let me know. But it is, it is a hard read considering it came from two people with PhDs in mathematics. Cause they took the really complicated mathematics stuff and added in neuroscience and psychology and biology and several other sciences, talking about what makes the games more engaging and more interesting. So the original one is a very difficult read, but I can dig that article up if anybody wants to see it. Everything on the list here. Yeah, so just a few notes about probability. We'll see this in code. Just think about what makes the most sense to you. And well, like this week we started our first group project. So also think about how they relate to each other, right? If I change this to 12, then it would work out more even. The 12-sided die, so 33% chance, 1 in 3 odds, or on a 12-sided die, less than 5 would be 4. So that's 1/3. So all 3 of these are the same thing. So if one of your group members thinks about it a little bit different, just try to make sure that you can kind of go back and forth between them. Right? Most calculators have a fraction button anymore. So if one of your teammates for the group project likes to use percentages and they type in all these floating point numbers and stuff, and you're having trouble with making sense of it, just punch that in a calculator and hit the fraction button to see what that would relate to is in terms of odds. And think about the English, translate it to how we would talk about those things talking to our friends, because things like percentages and odds do show up in our daily lives. Chances, stuff like that. Any questions about that? We'll see that in practice as we get into some examples and stuff. Okay, I'm not hearing anything, so I'm gonna start up some breakout rooms. Maybe. Where are the breakout rooms? Button for breakout rooms moved. I have to try to find it. Well, let's stop the recording, and then set up some breakout rooms. Oh, I gotta do it on this computer. That's why it wasn't working. I have to do it on the actual host computer. So, that way you can talk to your classmates and stuff. So I'll go ahead and stop the recording, set up those breakout rooms, and then y'all can figure out what the best method of communication for your group will be. So stop recording.